Okay, we're back in our overlay demo MXD, and this time we're going to do a fuzzy overlay in the fuzzy overlay tools. And we're first, as I explained, first for your inputs, you have to apply fuzzy membership classes and then perform the fuzzy overlay. So we are going to go into our toolbox. Let's go into our overlay toolbox, and instead of a weighted overlay, let's make a new toolbox. I'm going to right click here and make a new model, sorry. And I'm going to go to model properties and store relative path names. I don't know why they don't make that the default. I'm going to call this fuzzy overlay, and the model will be fuzzy overlay. And here's where you put in your description: Geog 481 demo of fuzzy overlay for 2420, and then I'll say fire hazard. And then in the end, I have you go above and beyond if you want to do more. You can bring in discrete variables, etc. Okay, so now we set our environments, and we want to set our processing extent, raster analysis, and workspace, our three main ones. So I click those there and I go to values, and my workspace I want to set to output in my overlay folder. Same for this. I could have cut and pasted or clicked on it. Processing extent I want to set to my Malibu DEM. Cell size I want to set to my Malibu DEM. And my mask I'm going to set to the Malibu, which is the polygon of the city, so it clips to that. Okay, so I've got my model ready to go. I've set my model parameters. I'm going to save it. And now I'm just going to bring in my DEM, because it all starts from this beautiful data set, the DEM. And so we're going to do, first we're going to calculate elevation and then slope. We're going to calculate slope in percent, then aspect, and then we're going to apply the fuzzy membership classes. So I'm going to go to my toolbox here. Under my surface tools, I'm going to drag in slope. And why not, while I'm here, I'll drag in aspect. And first we'll calculate slope in percent. So I'm going to click slope, and the input raster is Malibu DEM. And the output, I'm just going to delete all that and do SLP PCT, and it's going to put it in the right place, trust me. And this is going to be percent rise. Oh, it doesn't like that because I already have one that's called that. I'm going to call it slope percent. Percent rise, apply, and okay. Isn't Model Builder the best? You guys are probably like, why don't you teach us this in week 2? Aspect. And the input raster is the Malibu DEM. We'll call it MAL-ASP or MAL-aspect or something like that. Again, it's not a good idea to call something the name of the tool. So we have Malibu aspect, and I'm going to go back into my Word document, and I believe I just do elevation. So here's, sorry, now we're back into fuzzy. I have information on the fuzzy, screenshots of the fuzzy membership types, and I talk about those. For elevation, we're going to use linear. For slope, we're going to use large, and for aspect, we're going to use near, just like I showed you. So I'm going to, oops, I don't want to do that. I'm just going to minimize this. I'm going to bring in now my fuzzy membership classes. So I'm going to go into overlay, and I'm going to bring in my fuzzy membership tool, so I can assign my fuzzy membership classes. So the first one I'm going to do is elevation, and you know what? I'm just going to do it here. I'm going to organize my model this way. So my first fuzzy membership is going to be on elevation. So I'm going to take my input raster, which is the Malibu DEM, and I'm going to call it fuzz elev, and I'm going to make it linear. And it finds the ranges of values in there, and it's just going to assign a ranks of 0s and 1s linearly along those elevations. So you can make it more complex. These are the different options you have. there's small and large, and then there's mean and standard deviation, MS large and MS small. So it calculates the standard deviation and mean and applies things that way. So it's a little bit more complex. So I actually didn't have those in the slide part, but you can go through these different classifications, and these are the different options you have for creating your suitability assumptions. So I'm going to click apply and OK, and I have my fuzzy LF. I'm going to apply large to slope. Fire is more likely to occur on medium to steep slopes and increase as slope increases. So we're going to assign the large fuzzy membership and 0.5 at the midpoint of the range. So anything that's a midpoint of the slopes is going to get a 0.5. Anything that's less than that gets, values all the way from 0 to 0.5 and then 0.5 to 1. So that's how we're going to assign our fuzziness to slope. So I'm going to bring in fuzzy membership again. And I'm going to bring in my slope percent. And I'm going to call this slope fuzz. What did I say? Large. I'm going to make it large. And the midpoint is going to be 0.5. I said large, right? Yes. Pretty simple, right? Now we have our fuzzy slope, and then we have our fuzzy aspect. One more time, third time's a charm. Remember my theme here? Every time I have you do something, you do it 3 times. You learn it. Fuzzy membership. So we're going to bring in aspect, and this is the weird one, Malibu aspect, and we're going to do fuzz aspect, or this one we're going to do near, and the midpoint is going to be 180 because anything that's 180 is south, and that's what we're going to apply to the near. And so we have our fuzzy aspect, fuzz LF, and slope fuzz. So what Lauren Bennett did was she had run these, and she clicked back and had them already nicely available in her MXD. So we could, if we want, just run this part of the model. We're not done yet. We just have our fuzzy inputs, but I could run the model and we could see what these look like. And then I will delete the intermediate data. And then the last part is bringing in the fuzzy overlay, which is a complexity in and of itself. So I'm just going to save my model just for demonstration purposes. And I'm going to add these to the display just so we can see what these look like based on these classifications. So I'm going to run my model, and hopefully it runs. So we have fuzz LF, a range of 0s to 1s. Slope fuzz, oh, something happened with that one. An aspect is 0s and 1s. Something's wrong with my slope. Maybe I don't have a midpoint. I'm gonna have to redo the slope fuzz. Well, I'm glad I did that. So fuzzy aspect, so if I do so we can look at these and you can symbolize it. It goes from 0s and 1s based on south elevation. This makes the most sense. I don't know what happened with my slope. I'm gonna have to redo that one. An aspect looks like it's mostly 0s and then high values where it's, but there's some ranges in there. And we could do what she did. I mean, I could have had this already there, and she had ranges of greens to reds. But okay, I need to change my slope. Let me go back. Something's weird with the slope. Did I not put a midpoint in? I have to redo slope. So I could pause the recording here. I didn't put a midpoint in. Maybe that's it. I'm going to try this again. I'm going to remove these. I'm going to not add this to the display right now. I'm just going to run it again and just do the slope fuzz, add to display. But first I'm going to do delete intermediate data so I can get rid of the ones that I already created and double check. I don't know why I didn't delete it. Model. Oh, because I had it. All right, I'm going to just delete some things in here. Delete. I don't want to delete that one. I just want the fuzzy one. So those are from before. I'm going to delete that. And I'm going to delete that. Sorry, bear with me.
If you pause the recording, can you make sure that the way you fixed it is in there as well, though? In the video.
Oh, did I pause?
Did you say you were going to pause it?
I didn't pause it.
Okay, that's
We're getting
perfect.
into this. Thank you. Do you want me to pause it? I don't know why. Just fast forward through this. Just know that life doesn't work as easily as it does in the videos.
Yeah, I'd rather see how you fixed it that way if I follow along.
I don't know. I'm going to just try it again and only add slope to the display. And let's see if this works. But you saw how they were all in classes of zeros and ones, right? Based on the membership we did. It's stuck on something. Oh, I may have to pause it and troubleshoot. It doesn't like something. It didn't like hello. Maybe because I have something already named that. I don't know why it's not working now. I'm going to pause this for a second and maybe you guys can get a coffee. And then I will fix it and we'll come back. Okay, so I got the slope fuzz to work. It may have been the midpoint, but it looks like a lot of the values are zeros. So I'm going to go to properties. We can classify it and see if we have anything. Yeah, it looks like most of them are zeros, except for a few areas in here. So we may need to, oh, that's no data. We may need to tweak this a little bit. I may need to tweak my slope fuzzy membership classes, but I'll get back to you on that. The slope fuzz is weird. Maybe I'll pick a different membership class for slope. I'll get back to you on that and maybe edit the lab accordingly. So there's an issue with the slope classification. But I'm going to turn off add to display and I'm going to go to model, delete intermediate data. So let's assume, and for the purposes of demonstration at least, that we have zeros and ones based on these fuzzy membership classes. Maybe I just need to tweak the slope one. Oh, maybe because I did linear. Did I do, oh, that's LEB. Linear is LEB. LEB is linear. That's okay. Slope fuzz. Maybe I'll do MS large. I don't know. We'll try something else. And for some reason, it's not, I'm going to delete that. Okay. Well, anyway, now that we have ours, let's assume in a perfect world that it worked like Lauren Bennett's did, and I was a YouTube star like she is at Esri. And my things worked. And now we have our zeros and ones, zeros and ones, and zeros and ones. But the last part, and here's the complicated thing that we need to do, is pick a fuzzy overlay operator. So if you open up fuzzy overlay, there's different operators. There's and, or, some, product, and gamma. And I'm just going to call your attention to the tool. So what and does is take all of the 3 zeros and 1 grids, and the minimum value is assigned. So if a cell is a 1, it gets a 1. If a cell is a 0, it gets a 0. So it's very conservative. So if anything's a 0, it's like a Boolean and, right? If it doesn't matter if it's 0, it gets a 0. Even if they're 5, 5, and even if they can't be 5s, even if they're like 0.9, 0.6, and 0, the cell is going to get a 0. So the result usually of and is a lot of zeros. what OR does, what OR does is it takes all of the inputs and it takes the maximum. So if you have a 0.65 in one grid cell, a 0.35 and a 0.25, the result is going to get the 0.65. So it takes the OR. The OR takes the maximum of that. So how representative is that? I don't know. Sum adds them all together. So I like sum the best. So sum will take the combinations of all inputs. And then gamma takes the fuzzy sum times the fuzzy product. Oh, so product is these get complex. A decreasive function. Use this when the combination of multiple evidence is less important or smaller than any of the inputs alone. So there's a lot of complexity behind these different overlay types. In the lab, I'm going to have you put in a bunch of different ones and see what they look like. So the input rasters are going to be, oh, I have to actually do this from within the tool. I'm going to bring in fuzzy overlay, and the input rasters are fuzz LEV, slope fuzz, and fuzz aspect. I kind of named these funny. And I'll call it fuzz sum. We'll do fuzz and I'll do the overlay type and. This is going to make them mostly zeros. And then I'm just going to copy this a couple different times. I can copy the tool if I do copy and then paste, and then just double click the tool again. It has my grids in there, but instead this will be fuzz sum, and I'll make this one the overlay type sum. And then I can copy it again. And this one I will make OR, and I'll call it fuzz OR. So you guys can do some more with this. So we'll have 3 different outputs. So not only do you create your fuzzy grids, but then you sum them, or you AND them, or you OR them. All right, so let's hope this works. I do have an issue with a membership class, and I need to go back and revisit that. But for now, let's run this and see what we get. And I will put these, I will add these to the display. Let's hope this runs. I'm gonna actually save my model, close my model, and reopen it, because that seemed to work last time when it wasn't working. Let's just double check and make sure this doesn't have an exclamation point. Okay. Oops. Okay, I'm gonna run it and hope that it runs. And then we can explore the output. So hopefully you get a sense of the complexity and appreciate the different ways of how you can, how important it is, honestly, how important it is for you to be very communicative about what your assumptions are, what your input data sets are, and what you did in your output. Because there's a lot of complexity that you do in the analysis. Ultimately, the only thing somebody's going to see is your map. So your map really has to include all of this information. Okay, so we have a fuzzy OR, fuzzy sum, and fuzzy AND. So our fuzzy OR, remember the fuzzy OR is going to be the OR, the maximum of any input in the raster, the AND is the minimum, and the sum adds them. So the OR is the maximum, so it goes from 0 to 1, which makes sense. So I kind of like the fuzzy OR, and I like the fuzzy sum. I think the fuzzy sum takes the average of them. Those are my 2 favorites. So I'm going to go to properties, and I'm actually going to classify these in oops. Where is it? I like that one. Keep losing it. Here we go. Okay, so here's my fuzzy OR of fire hazard. So it's based on these assumptions, it's showing these areas have more hazard. Here's my fuzzy sum. It's showing these areas, different hazards in probability in ranking of 0 to 1. And fuzzy and is going to be very low most likely because it has just the low values. I'm going to go to properties. And so it depends on the analysis and how you want to represent something. So we could do product and gamma as well and add those in, but I just wanted to give you these two examples. And then say you wanted to tell somebody, so here's fuzzy sum, and how does that compare to your weighted overlay, right? Here's your weighted overlay of 1 to 5, and here's your did I remove it? Here's my weighted overlay. I took out my weighted sum. Where's my weighted sum? I'll put that back in. Here's my weighted sum. Remember that one? Okay, so weighted sum, that's based on vegetation and slope. Weighted overlay, it's based on vegetation soils, right? What do we have that based on? Vegetation and soils and slope and weighted overlay. And then here's our fuzzy sum, our fuzzy and. So it's different ways of representing fire hazard. So let me go back to this integer thing. So these, you can't, so really what this is assume that this output from the fuzzy overlay is probability of fire hazard. So to get at what that probability is and to actually make a table, which is what I'd like you to ultimately do, is the last step. And you could do this in Raster Calculator for each of these. In fact, I don't have you do this in Raster Calculator, but I'm going to do it in this demo. Am I paused or am I on? I'm not paused. Okay, I just want to make sure I'm recording this. I'm going to go back in and go into, where is it? I want to edit my model. Why is it not letting me edit it? Oh, because it's open already? Uh-oh. There we go, edit. Phew, it was open already. Okay, so at the end, I'm going to bring in Raster Calculator. I'm going to get back to our map algebra, Raster Calculator. And for each of these, I'm going to take my fuzzy and I'm going to actually do integer. I'm going to make it an integer. Integer. And I'm going to make my fuzzy and. Well, I'll do the fuzzy or and the fuzzy sum just so you can see it. Fuzzy or. And then I multiply it by 100. So, and this will be, we'll call it fuzz or int, or fuzz or I. Or I. So it's taking the grid, and I'm just going to set this off. So it's converting that to an integer and multiplying it by 100. And let me just do it outside of Raster Calculator because I've already run this model just so you can see what I'm doing. I'm going to open up Raster Calculator. And for example, I'll take, I'm going to make integer fuzzy sum, and I'm going to multiply it by 100. So it's going to convert all these values from 0 to 1 to 0 to 100 so we can know what the probability range is. And I'll call it fuzz sum I for integer. Oh, why is it going there? That's not where I want it. Oh, that's not what I wanted to do. Shoot. That didn't do it. Here. Go back to my lab. Integer. Oh, I did the multiplication times 100. It has to be inside the parentheses. Let me try it again. I'm going to go to my raster calculator and I'm going to do here. It's integer fuzz or times 100 in the properties. So it's integer fuzz or times 100. So that should work. I don't want fuzz or, I want fuzz sum. Lots of versions. Let's see if this worked. There we go. So now I have it in integer values of 0 to 1, and it has an attribute table because it is a it's not float anymore. So here you have the count. So you have 20,000 cells that are ones, right? So and 16 cells that are 100. So if you wanted to figure out what the total area is, and I showed you this previously in the other example when we had weighted sum. If I highlight 75 to 100, which essentially could be equated to probability of fire hazard, percent probability, 75% under these assumptions. If I go to statistics, it tells me the number of grid cells that meet that criteria, and I multiply that by the grid cell resolution, and that gives me the total area of cells that are in this high hazard area, given the fuzzy membership classes that I chose and the fuzzy sum representation of that overlay. So I need to change this too. Do that again. It's int, and then you take fuzz sum times 100. Like that, because I already have one named that. So that's how you convert them to an integer. Okay, so that is my demo of fuzzy overlay, fuzzy membership, and I will get back to you. I will revisit the slope membership classes and try and figure out why they weren't as ideal as I had intended. But we can just actually bring one. If I changed it to large, I'm going to see if what that looked like, the second fuzz sum, and see what that looked like. That was a little bit better, actually, when I changed it to, no, I'm sorry, not fuzz sum. I want fuzz slope. I deleted the slope fuzz. Let's see what that one looks like. Yeah, it looks a little bit better when I did that. I changed it. So the slope fuzz, when I did MS large, and I didn't have the midpoint in there the first time. So I'll go back to my model, and then you can see what I did. For the slope fuzz, sorry, not that one. I want this one, fuzzy membership class. I made it MS large. So it took the mean and standard deviation and applied that to classify it, which turned out better. Okay, so that concludes my material. What I want you to do in the lab, so here's what I have you do. I've written all these steps out, and the last part of calculating the values of fire hazard, I want you to be able to, and I know I've given you a lot of work, like, so you have a bunch of different labs. In this one, instead of making a map, okay, so what I suggested is extra depth on your own. If you want to bring into the fuzzy, you can bring soils data, vegetation data, you could do it on your own. Baseline, repeat this on your own. Make your own model, because I didn't give you the model. You're gonna have to make your own weighted overlay and fuzzy overlay model. Change the ranks if you want to. Change the weights if you want to. So the baseline is redo the steps in this lab, change the input assumptions and model parameters. Whoops, typo. In a write-up, so you're just gonna write up for me, I want you to explain overlay analysis. I want you to put in your own words the difference between binary overlay, weighted sum, and fuzzy overlay, and describe the fuzzy membership functions to the best of your ability for the introduction. Procedure, I want you to describe what you did or in your own words, what we did, what your assumptions were. Put a table in there of the data sets for each one, for weighted overlay, weighted sum, and fuzzy overlay, and what your criteria were. And then provide a screenshot of the 2 different spatial models for your procedure. And then in the results, I want you to describe the results from each overlay operation and select one of the outputs and make one of those tables and tell me what the total area of fire hazard is by converting it to integer. And then summarize what you learned, maybe expand on it, for maybe what would you do besides fire hazard? How could you apply this? What kind of other suitability analyses could you do? Like think the bald eagle at Big Bear Lake, or some other kind of application that might be relevant to you. So it's a write-up that shows me that you went through the steps on your own, and a screenshot of your spatial models. So hopefully that makes sense. And then extra credit, if you go above and beyond and you want to take the DEM that you got from the previous lab and use that, bonus points. Sound reasonable? I've lost participants. Oh my God, you guys are dropping like flies. Sorry.
It makes sense.
Professor?
Yeah.
Yeah, this was pretty tough, this one. So when we go and figure out our own input assumptions and model parameters, I mean,
you can follow my steps in the lab.
Yeah, it's sort of like, I mean, I could spend forever trying to figure that out. And
I don't know, just change, instead of 20%, weight it 30%. Like, I don't care what you do. You could, if you wanted to go above and beyond, like you could change the rankings, but otherwise, just instead of 35% influence for vegetation, make it 20, or slopes 40. Or do it the same way. I don't know, whatever works for you. I don't want you to freak out and blow you. Like, just go through it yourself. And then once it's in the model, it's easy to change.
Right. Okay. And when we're done with people asking a question, I have other questions, but not related to this really. It's just some basic concept. So I just want to clarify, since we're coming towards the end of the class and all that. But so yeah, if I could just ask you those questions at the end, that'd be great.
Okay. Do you want me to stop recording now, or do you want me to keep recording the questions? I'll keep recording. I'll stop recording now because this is the fuzzy part of the lab, and then I'll record the questions.